Welcome to the Mood Ring Part 1 Exploring Color. In this video, we're going to do an overview of Activity 2. In Activity 2, we'll talk about electromagnetic waves, electromagnetic radiation, and the electromagnetic radiation spectrum. Use one of the methods that we've learned in previous videos to navigate to Activity 2. It's probably on page 1.15. Pause your video now and resume when you've reached Activity 2. Activity 2. In the previous video, Explore More, you may have heard me reference electromagnetic radiation. Electromagnetic radiation is one of the most important phenomena in the world around us. You are very familiar with it, you just may not know it by this name. We perceive a narrow range of electromagnetic radiation that's called visible light. But there's lots of other radiation that's out there that we cannot perceive, and well, we may think that it doesn't even exist since we can't see it, but it does exist and there are ways to see it. Let's proceed to the next page to look at a very important graphic that shows, first off at the top here, electromagnetic radiation as a wave that can vary in terms of how big the wave is. So if we're going to talk about electromagnetic radiation as being a wave, well, what's waving? Well, this gets to be kind of an advanced topic, but there is a feature of the space around us that's called the electromagnetic field. And the electromagnetic field is a property of space, and well, it's kind of like ocean water. It's just that we don't feel it, but it can have waves. And just like waves in ocean water that carry energy, after all, if you've ever had the opportunity to play in the ocean and you've been hit by a big wave, you know that wave transfers a lot of energy. It can knock you over. Well, so too do electromagnetic waves transfer energy. It turns out that there are many different wavelengths. The wavelength is the distance in meters from two successive wave tops. So imagine looking out on the ocean and seeing a set of waves rolling onto the beach, and you were to look at the white crest on each wave and ask, what is the distance between those two waves? Well, that's the wavelength. And the wavelength of ocean waves can be, it depends, but 10, 15 meters. Electromagnetic waves also wave, but they have a large range of lengths. And that's what this graphic shows us. Very long waved electromagnetic radiation is what we call radio. So for example, your cell phone works by radio, and when you text message someone, that text message leaves your phone as a radio wave, and it is transmitted through space in the electromagnetic fields, and that wave jiggles, so to speak, the cell phone of your friend that you're trying to text. So there's really a wave that goes from your phone to your friend's phone, just like waves in the ocean. And the waves of the cell phone are someplace around radio waves up to microwaves. Microwaves that are in an oven also are electromagnetic radiation. And so there's kind of a radio transmitter that's inside of your oven that's transmitting microwaves that excite the water molecules in your food and get them energized and warm them up. Still shorter waves are called infrared waves. Infra, it means below, And it's red because these are the waves that are just below visible light. Infrared light is all around us. In fact, our bodies actually give off infrared light. Again, if you watched Explore More in the previous video, you learned about infrared light that our bodies give off. Now comes the band of electromagnetic radiation that you're very familiar with called visible. Visible starts from long waves that are red and proceeds through all of the colors of the visible spectrum. That's Roy G. Biv, if you're not familiar with that. Roy G. Biv are the colors of the spectrum: red, orange, yellow, green, blue, indigo, and violet. And you can see those down here on the bottom. And our eyes have evolved to detect those lengths of electromagnetic radiation. A still shorter wavelength of electromagnetic radiation is called ultraviolet. Ultra means beyond. Violet are the shortest wavelength that we can see. Above ultraviolet are X-rays. X-rays are very short wavelength that are very penetrating. They can actually go through our tissue and examine our bones. And still shorter waves are gamma rays. Gamma rays are ultra short, high energy electromagnetic waves that have a wavelength that's about the diameter of an atomic nucleus. So they're very, very small. Just as we talked about ocean waves having energy, well, these electromagnetic waves have energy also. Electromagnetic radiation that is above ultraviolet, and including ultraviolet, are sometimes called ionizing because they will knock electrons out of atoms and change their atomic and molecular structure if they happen to be in molecules. This ultraviolet radiation and higher can actually kill bacteria, which sterilizes things like our food. And so electromagnetic waves also have energy, just like the ones in the ocean. I would like to do a little demonstration for you, but before we do, I want to pause the video and let you examine this spectrum in more detail. Take a look at the names of the different types of radiation and look at their relative wavelengths. So pause your video now and examine this diagram. After reviewing the electromagnetic spectrum diagram, you saw that electromagnetic radiation is a wave that has a wavelength. The wavelength can be very long, the size of buildings, those are radio waves, all the way down to the very short, the size of an atomic nucleus, that are high energy gamma rays. Let's do a quick little experiment to investigate one of the rays that are just before visible, and that's infrared. Remember, infrared are waves that we cannot see with our eyes. I have my remote control here from my TV, and I'm going to take it and I'm going to point it into my video camera here. And when I do that, I can press some of the buttons that control the TV, and when I do that, you'll see a light flickers in the end of the remote control with a little flash pattern that has a code built into it. When I point the remote control at my eye, I don't see anything at all. That's because the light inside of my remote is an infrared light. And so my eyes cannot detect it, but there is a device that's built into the TV that can detect it. So there's all sorts of electromagnetic radiation that surrounds us that we cannot perceive. Here's an example of that, infrared radiation. I also want to show you one of my favorite pictures from astronomy that is made up of multiple different wavelengths of light. This is a composite image of M81, a spiral galaxy about 12 million light years from Earth. And this spiral galaxy was imaged by about 5 different telescopes all at the same time. Each telescope viewed the image in a different wavelength of electromagnetic radiation. The most prominent feature is this expanded view of the center of the galaxy, which shows from the Chandra telescope the X-ray view of the galaxy. It turns out that in the center of this galaxy is a giant black hole that gobbles up stars the size of the sun, and when it gobbles them up, it gives off a puff of electromagnetic radiation that is in the X-ray wavelength. In addition, you can see that there is a purple halo around the edge of the galaxy that is visualized by the GALEX space telescope that has imaged the same galaxy in ultraviolet. So this is all ultraviolet light. There are detectors built into these telescopes that are sensitive to different wavelengths, kind of like the TV remote. The green color comes from the Hubble Space Telescope looking at this in visible. In visible light, you don't see all of the structure that we see right here in this multi-band image. The pink color that's kind of in the central part of this comes from the Spitzer Space Telescope that is viewing this image in infrared. And then the whole image has been analyzed with the radio telescope at the same time to make sure that all of the images are aligned. So when we look at this composite image, this is an image that we would never see with our eye could we put our eye up to a giant telescope. Instead, it's an image that's made from several space telescopes that look at the galaxy in different wavelengths of electromagnetic radiation. And the galaxy looks different in each of those wavelengths, and scientists can use the information from the different wavelength images to do physics to understand the spiral galaxy better. Well, I hope that you've learned about the electromagnetic radiation spectrum and all the different wavelengths that are possible. Well, this concludes our activity. Please stay tuned for the next video.